Game data.
Hello, everyone, and welcome to the third episode of the Game Data Podcast. Today's episode, I talk with Macky and Will, formerly of League of Geeks, about their work on Solium Infernum. It's a really good conversation. Solium is a huge game. It's also an amazing game if you like doing 4X battles in hell. Highly recommend it. We talk about their unique simulation engine that underlies all of Solium. We talk about how they save their data, how the data is authored, all that good stuff that you come to Game Data for. So grab a cup of tea, grab a coffee, sit back, relax, and enjoy the show. Thanks for listening.
Game data.
Hello, everybody, and welcome to another episode of the Game Data Podcast. This is episode number 3, and today, for the first time in Game Data history, in our now third episode, we have a special, which is that we have 2 people who worked on the same game. Episode 1 for us, we had Arnold from Tiny Touch Tales talking about his kind of personal game. Nick Tringali was talking about working on Banished Fault, albeit with a team. But today, I'm very excited to have both William Dyce and Macky. I just forgot your last name, Macky. I'm sorry.
I just go by Macky. It's like Shay,
Macky. Yeah. From League of Geeks, or formerly of League of Geeks, who worked on the honestly incredible, strange, weird 4X remaster of much loved weird hell strategy game Solium Infernum. Will and Macky, welcome to the podcast. I'm glad to have you.
Glad to be here.
Yeah. So we've got, I'll just say this up front. If you haven't played Solium Infernum, you should go play it. But I know that at the top, like, this is the biggest game that I have talked to people about. Everyone else has worked on sort of like mid to smaller tier stuff. So I am excited to have that perspective of like, this is, I mean, I don't know if you guys would consider yourselves AAA, but like this is a big strategy game.
Oh, triple I.
By all intents and purposes. Triple I. Yeah. Maybe like quadruple I. Like it's a big game. And then for people who don't know, I don't know if either of you want to give like a, 2-minute, 1-minute rundown of like what the hell Solium is. If that's possible to do in that amount of time.
Yeah, I guess you could describe it as diplomacy with demons. If you're familiar with the board game Diplomacy, which is
that's not bad. Yeah, it's pretty good.
Yeah, so diplomacy is kind of like Risk, but it's all about planning your moves simultaneously with the other players. Everyone submits what they're intending to do, and then you find out who has stabbed you in the back. The Game of Thrones board game picked up sort of similar ideas, and with Solium we've packaged that all together into a kind of Miltonian vision of hell, and we've included a really nice sort of multiplayer networking infrastructure that lets you play games asynchronously with a bunch of people at the same time. It'll ping you on Steam when your turn's ready. You just take your turn and yeah, so go play it. It's great.
You should. And then I guess just for context too, Macky and Will, if you can say generally what you did on the project. So when you're talking, people have sort of context on where you're at around the project.
Yeah, absolutely. So I was a senior technical designer on the project. So I was working on system and content design, a lot of balancing and tuning, and a lot of sort of data entry and implementation as well.
You also did a huge amount on the AI as well. Don't undersell your work there. That's
true.
And yeah, I'm Macky, and I was the tech lead for the project. So I worked on high-level architecture and just a lot of things in the simulation core.
Yeah, awesome. And so Macky, we've never met before besides this episode, but I will say the first time I met Will, I had walked by him at, I guess it was Gamescom.
Yeah.
And you were smiling at the computer. And I went to like talk to you. You were alone, by the way. It was just you in the booth and you were smiling at the computer. And then you like turned around and were smiling. But I don't know if I introduced myself yet, but you're like, oh, the AI just did something really cool. You're just like stoked, just like there by yourself, just being like, yes, my sweet, darling child has impressed me once again.
Oh, you're so often disappointed when the AI does something, and you kind of open up its brain and put the spoon in and sort of mix around. What are you thinking? And then you go, oh yeah, all right.
I guess that makes sense. Yeah.
But so there are some great things. Like I've seen a couple of Steam reviews recently where a player was brutally murdered by the AI out of the blue. And I just look at that and go, oh, they grow so quickly. All grown up.
That's great. I mean, maybe we'll get to AI. But you guys know what this podcast is about. It's kind of like to pick up Will's analogy of opening up the head and scooping out the brain. We dig a little bit deeper on this podcast than you might in other podcasts just talking about the game. So let's just start out. We'll just do a really high level question. And Macky, maybe this one's for you. It's like, what was the sort of overriding technical architecture vision for the game? Like as like an example, like for Cantata, which I will bring up in every podcast because biggest thing I've worked on, like the whole game was just effectively a giant command queue. Everything could, emit a command that went into a big queue that would be sort of executed. Those had outcomes. How was Solium kind of architected, I guess, at a high level?
Yeah. So probably one of the biggest driver of the architecture was that we really didn't want to have our server architecture be Unity deploys. And so we really focused on making our simulation core and everything that was needed to drive the multiplayer experience completely agnostic from Unity. So building that as a separate library. And
then just to interrupt you, was that .NET, C#, Node?
Yeah, just raw C#.
So just raw C# like running on the server.
Yeah. So then that was done in PlayFab and Azure Functions, essentially. To just create our little game context, essentially, and start processing the tones through that.
And then for I guess, just to stick on this for a second, that is for like remote servers. That same simulation core, was it also deployed locally for like local matches?
Yeah,
exactly. And you just kind of had two copies. Gotcha. And then how were you managing sync between like that library and because the cloud functions, if I remember, sort of deployed individually. Yep. How were you kind of syncing the two of those?
Yeah, so we had some really good automated pipelines through our Git merge process. So whenever we did like a release version or whatever, we could tag it, and then it would deploy to the correct servers, and then we would just need to have like a single manual swap button to just swap the latest server version in once we deployed on Steam. And so it was almost like the the quintessential turning of the keys, simultaneous key turning to launch the nuke kind of thing, where I'd be standing by ready to deploy on Steam, and our chief server engineer would be standing on the other end ready to deploy the server, and we'd just hit the buttons at the same time. Yeah. So
it was like developed like for sort of local simulation work, but then deployed to the server effectively with like VCS hooks. So you'd merge, tag it, and then it would update.
Yeah. And we had some really nice tech in there as well for just automated sandbox deployment as well. So it would go via the Git branch. So if we had a Git branch that was like tagged like release, it would just take whatever that branch is and then make sure it was updated and deployed correctly too. So we were able to do beta tests with separate branches simultaneously, as well as any sandbox build that would be just built as like a nightly or from the latest merge could be tested with QA online as well. It would just automatically update and tag. It was really powerful.
And then I guess, so calling local functions is different than calling remote functions. What was actually going to the server versus going local? Like what was the actual kind of data that was being pinged, or, we're using something like an RPC? Like what was the, how do we distinguish between what's being called locally and what's being called remotely?
Yeah, so we had a kind of just some really light service architecture on the client to sort of manage that, which would just say like, is this a remote session or is it a local session? And if it was a local session, then it would just essentially send the turn order data, exactly the same data, to like local processing service, essentially. And then that would return to the same endpoint when it was done. It would just thread and come back.
Oh, you were literally running, so you literally run like a local server effectively for a local client that's just serving the API? Is that?
Yeah, but not to the degree that it was using the same sort of webhooks. It would branch earlier than that. So essentially we had a kind of like iService that would be in charge of this, and then if it was a local game, it would just run in through local functions and come back. But yeah, the actual, like, as far as the game was really concerned, not a lot of additional stuff really.
Gotcha. And then I guess, Will, for kind of as part of this architecture and from a design perspective, was this like, I'm interested, especially in terms of you and like iteration speed, like branching to cut a new release for a server thing is really nice. Were you able to sort of leverage that to kind of make changes on the build, or did you kind of have to wait downstream until new remote stuff went live? Like, what was the sort of iteration and technical process for you about like interfacing with this system?
Yeah, so it was something we were always a little bit concerned about, which is, breaking games that were already running by changing the data.
Right.
How do you sort of hot patch, something that is running? But we actually had relatively few issues with that. It was quite a solid system. We were able to get in and modify all kinds of stuff on the fly. We were able to add new static data to the game, and it just simply wouldn't appear if you have a session that's already running that didn't include that stuff at the startup. So that was great, because the games of Solium, like I played one of the original that took a year to complete. And it's kind of the case with the new one as well. I find that it goes a little bit more quickly because you do get those notifications to kind of poke you. But you can still have games that go on for multiple months. And so the idea is you want to be able to patch, you want to be able to, maybe even release an expansion. We released a new Archfiend, a whole bunch of new content. And you want that to be able to integrate as seamlessly as possible. I can't speak to exactly how that magic was achieved. That's going to be the DevOps engineers, but certainly from the point of view of like almost a client of this backend stuff, I was able to work very freely without breaking everything, which was great.
Yeah, I guess like I didn't even think about that. Like, because the game it can be asynchronous. You have this like kind of what you're describing, where you could have matches that sort of occur over the span of months. So were you just like freezing the games? Like, were you saving sort of the whole state of the game with the save file? Like, how did you manage like potentially pushing hotfixes or patches, or even like sort of data patches, such that like what's like the contract, I guess, between you and the players of like a 4-month session? Is it that the attack power of this Archfiend will be the same for these 4 months, or like are they going to get buffed halfway through our session?
Off the top of my head, I believe that the attributes would be hot updated if they were modified in the static data, Macky.
Yeah, it was a bit of a almost a case-by-case basis. So when some entities are instantiated, they copy their data across locally. So for instance, we really didn't want to have a case where you schedule a turn knowing that your legion with its stats is going to move and attack something and definitely win, and then the game patch and you lose because we nerfed that base legion stats.
Exactly.
We never wanted that to happen. And so for a lot of those sorts of stats, we actually copy them across when the entity is instantiated, and then those persist. So whatever was in the static data at the time the entity comes into the game, that's what it's going to have going forward, regardless of the data changes that we made to balance it. Other things like damage from spells and things like that didn't have the same degree. So, if you're going to cast a spell and you was going to do like 5 damage or something, or 4 to 6 damage, and then we changed that from like 3 to 5 or something, that would patch through. But we kind of felt that the fickle nature of those abilities anyway sort of already had a bit of a social contract to say, this isn't guaranteed to work, whereas the combat systems are a lot more deterministic, and so we felt it was more important to maintain that determinism from update to update.
Gotcha. That's really interesting.
Now that I think of it, there's a side effect of that, which was because these scenarios, you have a set of almost chess puzzle scenarios to complete that ship with the game called the Chronicles, and because they're essentially save states, they do have the static data kind of copy baked into them, which means that we did various balancing passes on, for instance, the attributes of Pandemonium. Pandemonium got stronger, it got weaker at various times throughout development. But we had the tutorial, and the tutorial has the original stats from Pandemonium, like a sort of snapshot of what they were at a certain point in time.
We did build a system to help mitigate that. So when loading an old save in our developer console, in our Chronicles tab in that, it would go through and find anything that had base stats different from the static data and provide you a prompt whether or not you wanted to update it. But we also really liked it because it meant that we could maintain the balance, so to speak. So for instance, the tutorial, like as we were updating things, like Pandemonium's values may change, but then if we've already sort of configured a campaign with an understanding of the kinds of units that are already available in that session and what power levels they have, then it meant that it kind of stayed the same, and tutorials wouldn't get necessarily easier or harder, and it would just provide us an opportunity to come back in and retune manually and stuff if we needed to.
Yeah.
This is definitely such a hard thing. Like, Will, what you're talking about with the scenarios, just like, I mean, speaking from experience on Cantata, it was like a huge deal when, there's Fog of War in Cantata. You guys don't really have, I just don't remember if the scenarios have Fog of War, but like, and the way you move across the map, some things happen on vision, right? So like, if we were to play the whole game and then like realize later we wanted to change something's vision range to go from like 6 to 7, unless we remembered all the way back at like, mission 2 that there's a part of this trigger that triggers off of this, and there's just enough Fog of War where this unit can't see over this mountain pass, but now with 1+1 vision they're going to see it, then like it would sort of break the campaign.
Yeah.
So baking the static data I think is really smart. Oh, and then just like, the namesake, game data, what was that data, right? What did that look like? What was were you baking the whole scenario as part of the save file? What is it, like a diff? What is the actual data sort of format, and what's in there?
Yeah, so the whole thing is just one giant sort of JSON file that just has everything from the top down. So every game piece, which is anything that's on the board, what the player states are, and like what everyone's stats are. Everything we want to serialize is just in one big chunky JSON file that we then.
And that's the whole scenario, everything.
Yeah.
Gotcha.
And that comes back down as well. And then because JSON compresses quite well, because you've got lots of duplicated strings in there as well. So we compress it and stuff for the transfer to and from the server. And we did occasionally run into issues where we were serializing maybe a bit too much data at points that was causing a bit of a like, oh no, we can't actually send the game state back in a single thing, a single RPC query and things like that. We need to chunk it up and build in some backup systems for that. But generally we tried to keep it well below that. But every now and then we'd have some system that was just recording huge amounts of data, and we're like, oh no, why is it doing that?
I remember a negotiation with you about the way resources are generated, where I wanted to switch from using just like a random dice roll for the type of resource you'd get to using like a deck of cards that you'd cycle through, so you'd get all the types of resources. And you were saying, oh, we should just use a probability distribution rather than an actual list of objects, because that would be smaller because you're storing each state in the history.
Yeah.
So it was definitely a concern. We got to the point where like having a deck of cards in each turn state was maybe a bridge too far.
And then do you save? Is it like turn undo? Like, do you have? It's just like a big state. There's no like previous turns moves or anything, right?
No, we do store all that, but not in the release versions, and not in. But yeah, we do have all the save states, and that includes on the server as well. The server records all of the save states,
like per turn. So it just kind of like sends them, so you can play it back by just playing the saves.
Yeah. So it is deterministic as long as there is no version update in the middle. The simulation would be deterministic all the way through. Unless you did it from like you'd have to have multiple versions of the simulation core to propagate, right. And we never built that tech. But given a single collection of save states, if it's all in the same version, it is deterministic all the way through. So we can just replay the turns. And
how though, like, do you? So in Solium, for people who don't know, there is they're not favor tokens. What's like the currency called?
Prestige or
prestige? Yeah, prestige. Yeah, there's a lot of currencies. Prestige specific, the little coins, right?
Oh, the coins are called tribute tokens.
Tribute tokens. That's what I'm thinking of. Yeah. So the tribute tokens, you can use them to pay for like different things.
Yeah.
Is there always a one-to-one mapping between like previous state and next state, such that you can like infer what the actual action was? Because it seems like there's parts in the game where doing different things can result in the same action. So if like a value is 2 for state 1, and then in state 2 that value is 5, do you know what made 2 go to 5, or does what makes 2 go to 5 like always the same thing?
Yeah, I'm not sure if I fully understand the question.
Well, so you have the save states, right? It's like, let's say start of my turn 1, start of turn 2, right? It's easy in the case where I have a unit that is, at tile A, and then at save state 2, it's tile B. It's like they moved, right?
Yeah.
Unless, though, also, like, there's like a ritual you could play that moves a unit, so you don't actually know that it's a move. It might have been a ritual. How do you
store
actually
the
know?
orders as well, so we know what each player has actually planned as part of that save state.
Okay.
Yeah.
Okay, that's the piece I was missing.
Yeah.
Gotcha.
Other than that,
So you save it right before they end their turn. It's like this is the full turn.
Yeah.
Okay.
With all the states, yes. The way it actually works is what we do in that turn processing is a ready sort of turn for processing has all of those moves stored in it, ready to go, and we just duplicate, like do a deep copy of that game state to make the next turn, and then we just sort of remove. Well, we don't necessarily remove the actions. We just sort of like run those actions and then clear the list at the end, and then that's the new turn. Ready to go.
Yeah. Great.
I will say,
rinse and repeat.
as someone working on the AI and as someone, or testing or trying to do any debugging, it was an absolute boon to be able to scrub. I mean, the AI in particular, you could say, hey, AI, run for 50 turns, go away, make yourself a cup of tea, come back, and then just kind of step backwards and forwards almost as though you have a scrubber. It literally was implemented as a scrubber. So you could scrub back and forward.
Wow.
And you could see, turn 50, where, when was this character eliminated, or where did this character go wrong? And you could kind of look at different points in the game and isolate, okay, it's really struggling with this particular situation, and go in and do that. Go back to the same seed, rerun the 50 turns and see how things have deviated, So it was really an experience in playing around, almost like one of those films where, I don't know if you've seen Paycheck, where they're sort of predicting the future and trying to change things and get a different future. The AI. The reason I was grinning at that computer screen was the amount of time spent kind of, with the scrubber trying to get the AI to do different things.
Like, please. Is it, did you all have a way to sort of headlessly run the game? You mentioned the thing running 50 turns, like, and the game is deterministic, so could you like sort of run it without actually having to like watch 50 turns take place?
Yeah. So because the simulation core isn't actually Unity or anything, we can just put it on a thread.
Right.
So we could actually run multiple games simultaneously on multiple threads as well. So one of the systems we had would run multiple predetermined seeds at a time for like 50 turns, and so you just sort of push a button, and then like Will said, so I had to make a tea because it was a little bit slow. At least almost up until the end of development, essentially, before we'd really optimize the simulation core. Because, play turn to turn, you hit the end turn button and you just sort of throw it to a thread, and if it takes, a second to process the turn, then that's okay. But when you've got, 50 games, that's a minute, and you've got multiple of them running, and, sometimes we were running hundreds of turns of the game, not to mention having all the players be AI as well. So more processing there for each AI, and it could take a bit of time. But it would all just run headlessly, and so you just push a button, there would give you little bars that fill up showing you the progress of the turns, and sometimes you get lucky and one of the things would finish the game in 30 turns because somebody would win.
Yeah.
Were you using that for like, obviously it sounds like, Will, you were using it to kind of iterate and test on AI state, and I want to talk more about this in a second, but I imagine that, you could take any sort of output from this simulation engine and effectively render it inside of Unity and be like, what does it look like? If you want to see it. What did you use this for? Anything else like the testing? What else did you use this for?
Well, you want to go, Macky? It's your baby.
I really championed early testing, and in fact, in the really start of the project, before we'd even gotten like any real assets in the game or anything, we still really wanted to get a head start on our simulation core. And so we actually went with a test-driven design process. So we would write our tests first for the systems we wanted to build, and then using just the Unity
It's very non-game developer of you.
Yeah, using the test runner. Well, I guess, it's a simulation, right? So it's okay. We just wanted to check things like, hey, if I put in the command to move this legion or whatever from A to B, does it support world wrapping correctly? Does it get stuck if there's another friendly in the way and prevent it from moving? And all those sorts of like really basic things that we knew we were going to want to visualize really early and have those turns working. So we started working with those in that test thing. in that test runner. And I think by the end of the project, we had somewhere in the range of 2,500 to 3,000 tests.
Nice.
And I'd say about probably close to 75% to maybe 80% were all automated as well. Like a good example is with our Praetor dueling system. It's like each player has a Praetor and a card, and those cards have different effects, and then they sort of do battle. And we just knew that QA wasn't going to be able to test every card combination, so there's an automated test in there that'll just goes through the data, picks up cards, and then runs it against every other card, just in like an n-squared level operation. So there's like 400 tests that are just the duelings for the 20 cards that are in there. And we do similar things for like abilities. Every ability in the game already, whether or not that's like a ritual or anything like that, like any action you can really take, they all have data, and that data defines like the steps needed to configure it correctly, like and validate it. And so we have a test harness that automatically figures out for the AI how to manage that. So if it's like select a legion or select a unit or select an item or player or anything, the test harness knows how to do that, and it just picks the first valid one it can find, and there's sort of a scenario state set up to do that. So that'll automatically test every ability. So anytime we add a new ritual or anything, it automatically goes into the test harness to make sure it works correctly.
That's great. That's like the ideal way to do it.
Yeah.
We extended that logic of test-driven to the AI as well, because and this is something, as someone who's worked on AI design in 4X, turn-based games for nearly a decade, I've not done this before, which is probably, a bit of an embarrassment, setting really, really clear bars to clear for the AI. So we would of course have them sort of vaguely in the back of our minds, like, probably you should manage to build 3 armies by turn 10, or, if you've not done that, then something's wrong. But before Solium, I'd never actually encoded those into tests. And so because we had this framework for running tests, we had, various different ways of running them, either up in GitLab or down in the editor itself. There are a whole bunch of tests the AI needed to pass locally, like have you managed to raise a power to level 4? Have all of the AIs bought a legion by turn 10, or have they all captured a place of power or something like that? And that allowed us to detect regression really quickly. It was always a little bit of a kind of Groundhog Day situation, because the AI tended to catch a whole bunch of bugs that were not AI related.
Sure.
Or that
it's like
were
you have like almost like little agents that are just like, it's not like players play your game, right? And it's
it's like, it's not technically the AI's fault in this case, or maybe it is the AI's fault, but it's a bug that was introduced months ago that's only been surfaced by some random other change. But I think, on the whole, it was a really great way of ensuring stability, because Solium is a ridiculously complicated game. There are edge cases in the original that Vic Davies, the original creator, never handled. Like, I think Macky managed to blow Pandemonium off the map in one game. And the game didn't crash, but it was kind of in a slightly broken state from that point onwards.
You're like, oh, it was.
Yeah, I don't think we were able to get that game to end. I think there was no end state from that point.
I do want to talk about AI deeply. Not quite yet, Will. So I will give you your moment.
Yeah, sorry. Just keep chiming in.
No. I think it's great, because I think it's like, obviously it's a huge part of the game. I did want to stick a little bit on like the simulation engine, as you called it. How did you do sort of like realization between simulation and like the render? I assume the simulation is just popping out a save state. How is the game sort of like the runtime, like in Unity, interpreting that in terms of like what it's showing the player compared to what's currently being shown?
Yeah, so the very first thing we did was this kind of like sort of snapshot rendering, which is like the ability to just load a save, and like what would the world look like once we load. And so that's going through and looking at, say, like the game map, putting in hexes to say, oh, these are like the way that, these are where mountains are going to be, and these are plains and rivers and bridges and all that sort of junk. And then it goes through, same game state, grabs what pieces there are, and renders those and creates game objects and everything. So we have this sort of like initial setup state that can just take a game state and just render it flat, puts everything into an idle state. And then, because Solium doesn't there's not really a lot of action that's going on until you hit the end turn button, the simulation core then goes through, processes everything, and it returns a list of kind of like receipts. We call them game events, but they're essentially like the receipts of what each action did. And those are like nested. And so it's things like, this action kicked off this effect, when this effect kicked off damage to this unit, that damage caused that unit to die. And so we ended up with these like kind of clean chains of transactions of everything that happened. And then we had another system, which is the turn outcome sequencer, which would essentially, at the end of the turn when it came back, those game events would all be there. So when you look in the game, you'll see like the turn log on the right. Those are the same game events, just being interpreted by a visual system just to tell you about what each thing happened. That same data is exactly what's driving those visual outcomes. There's just a lot more data that is in those. And then, we have a turn outcome sequencer, which just goes through them in order, essentially, and shows you what you know and what you've seen. And those are just a combination of state machines and timelines to drive the visuals and audio and everything you see. And so, from there, same sort of deal. Like if there's a battle, it'll know where like all the units are meant to be, and if they're not in the places they need to be, it'll snap them there, run them through a simulation, and then at the end, it'll put people where it thinks it needs to be, and then it just moves on to the next thing and the next thing, which is also how the skip functionality works, because you can skip any event, and each one just goes, oh, okay, well, I was the one that was running, so I'll put things where I think they should be at the end. The next one runs and goes, I'll put things where I think it should be to start this thing. So if there's any disconnect between systems, like maybe a thing moved or teleported, but it wasn't recorded correctly or visualized correctly, the thing should still be in the correct place, so the visualizations will work. And that also allows us to sort of quickly skip to the next turn as well, so we can just snap to that next endpoint if we need to, because we have both states. So that system was essentially just translating simulation snapshot 1 to simulation snapshot 2.
So it's like, the sort of the Unity side is like dumb. It's like move this unit, but it doesn't know what move is. It's like
so it's
like it knows a move is enough to know to like move something around, but it's not like okay, now I'm going to deduct 2 move points from whatever. It's just like I'm moving this thing.
Yeah, no, it doesn't know anything about the simulation core. It's purely a just getting those events, like a choreography almost.
Right.
And it just feeds in those tickets of like, hey, move this legion to this thing, or run a battle, and then like, it'd be really interesting because you have like a really light ticket, like move this thing to this section, and then it'll have a sub event, which is like that battle was caused, and that battle chunk would be massive because like so much stuff happens in a battle that we want to visualize and all that kind of stuff. And especially when you're getting into states like, how do you visualize battles between 2 giant Titan enemies versus two ground armies, or a ground army versus a place of power? And so like the bulk of the simulations is really in that system. And that system is also what helps drive our tutorials as well. Like all of our tutorials are just kind of like running through that exact system, just happening not turn to turn. It's just still building the same sort of game context objects to say, move this legion from A to B, or focus the camera here. So like if we wanted to, the turn outcome system could still make use of like the same sorts of dialogue pop-ups that come up with advisors and things if we wanted to. We just don't, because it doesn't make sense contextually.
That's interesting. That's really cool. Yeah. Is that like, I'm interested in the system because this is like, the first time I ever encountered this was there was a blog post on Legends of Runeterra by Riot. This is the first time I'd ever really seen somebody publicly talking about like a headless way to run the game. It's very similar. They just have like I think theirs is all in Python. So they just have like a Python server, and it just runs, and it just, they turn off all the animation, like tweening, and the game's like, just like going super fast. But like, historically, League of Geeks before also did Armello. Was this like, let's do it right this time thing? Was this fully your decision? Like I'm interested in sort of the lineage of this type of system, because especially for something that is really simulation based, like a strategy game. And then, Will, maybe it's relevant for you here too, as someone who's like kind of working in this system. Like, how was the decision made to go this way versus, just like throw in behaviors on like mono behavior objects and just putting game objects in? How did that decision come about?
Yeah, so actually I joined post Armello. I never had the opportunity to work on it. And we started from scratch on SI as well. We inherited a collection of utilities that Log has. It's called Monolith. It's just like a NuGet package that has a ton of just really helpful utilities and systems for building games, which is built out of Armello and some other systems. But we more or less started from scratch in terms of all gameplay things, text rendering, everything, and a whole new tech stack for driving the gameplay. This sort of system was really driven out of that sort of really base desire to have the simulation core be on the server. And once we started down that path, this is just the thing that made the most sense, where we really wanted to make sure that, okay, if the simulation core is separate, then what is the communication between that core and the server? Realizing, okay, it's going to communicate in game states, which means we need a way of storing the things that happen to tell the player and that turn log. Realizing that, hey, that's all the contextual data that's happened. We can use that same data to drive it. It was just a very sort of like, what is the most logical step forward?
If you give a mouse a cookie.
Yeah, exactly. it all just felt very natural. These weren't some of those systems that we really didn't prototype any real alternatives for. It was always just a case of, if we do this, then we get that. And then, we can use that system, and we can reuse that system. And it just sort of all naturally flowed. Yeah, it was just really clean, I think.
Was like the architecture of the like rules engine itself, was it just like object-oriented programming? Here's your map, here's your units, they're moving, or was it like some functional transform thing?
Yeah, it's a bit of both.
Sure. Because
we went really early on with that sort of like test-driven development, we went for really testable functional programming. So, here's like the game state, and here's all the pieces that you need in a function to do something. So like if you're going to move a thing, quite early on it was like, here's the full game state, here's the turn state that we're currently operating on, here's the player that owns the game piece, here's the game piece that's moving, here's where it's moving to, here's how it's moving, all in like lots of parameters and as much context as possible. And then, we over successive refactors, it ended up being these full like move context objects that had huge amounts of data in them. Which is fine. At the end of the day, like, the thing we send to the server is just, I am this player, I am this game ID, I own this game ID, I want it to move to this location via these other locations. Like that's all. That's all the servers really did. That's all the communication protocol between the player and the game system. But then it would just build these huge context objects to actually end up driving that. Yeah, so we went with this really like sort of like functional thing. And otherwise, like if you look in the unobfuscated game state as well, like you'll see that it's all very like it's laid out. It's not very entity focused or anything like that. And that's because the team had previously come off a game that was using some of Unity's prototype ECS systems. Mm-hmm. It did not go well. Essentially, that system was not ready.
Was this the Starlight Odyssey team? Was it the same thing or different?
No. This is a different thing that never saw the light of day. I can't touch on too much.
Sure.
But yeah, it was using Unity's new like replicating editing system, and yeah, it didn't go well. That thing wasn't ready to scale. It was causing all huge amounts of problems, and so coming into this thing, as much as I really kind of wanted to go back to doing more of an entity-based simulation core, the team was just so fatigued on the word entity. I couldn't do it to them.
Don't say the entity word near us.
Yeah, and I was like, we're just going to go very object-oriented in terms of the layout. So, we have game pieces and like a game piece is like the top level thing, and then we have a specific game object that is, say, like a legion and a titan and things like that. And then over time and through that sort of like functional programming, we really kind of did pare it back to them just really being data and not really having a lot of functions, or if they did have functions, they were usually very, very simple, convenient things. They weren't doing like a lot of work or anything. And then so then we'd have lots of functions which would essentially be do this thing for me, like make this one atomic change, and that would typically return a game event, and then you would just chain that game event to whichever game event you were currently working within in a higher level. So calling into like the damage function could potentially call into like the kill or the capture functions. Those would also return game events, which you would then chain together to form those large coherency game event chains that I was talking about earlier, that really drive all that visual functionality.
That's awesome.
I can say from experience at Amplitude and with the sort of Sega strategy family in general, that when you're doing larger strategy games on larger teams, this headless mode tends to emerge as a kind of good, software design solution. You do want to be able to do, automated testing and run it quickly, and you do want to be able to port the game potentially to different platforms, and so there's a tendency, if you are using something like Unity, to just sort of gradually, shift the simulation code away from it.
I do. So I'm gonna start poking at the surface, Will, of some of the AI stuff, especially through what Macky was just talking about. So you did a lot of the AI, all the AI, I'm not sure, for Solium. Was like this, Were you working primarily in the simulation engine for like testing and kind of like producing AI states? Or like, maybe I'll just also ask the question, like, what was the sort of the architecture for the AI and how did that sort of interface between data and then stuff that was specifically baked into the simulation? Like, I don't know if you have like hard coded rules where it's like, if a unit moves here, then this, and that's just like part of simulation, or it's all just like some weighted data blob that gets passed as part of, Macky, when you're talking about like the move states having a ton of attendant data, is some of that stuff AI related? I don't know, Will, if you can talk about that.
Yeah, so I wasn't completely alone on the AI. There was Andrew, who was there before I arrived, who set up essentially the whole core architecture of it, which was goal-oriented action planning. And I came in to help out, and I wrote a bunch of stuff on top of that system and reworked various things as well, and helped him out. There wasn't a really kind of clear like DMZ interface between the engine and the AI, or not as much as say what we had on Endless Space. So there was a potential in certain areas to kind of cheat accidentally if you weren't careful. Macky, if I'm not much mistaken, you had, I think, the turn context and the turn state, right, as two sort of separate objects. And the AI had access to one of the two, which is the one that disabled certain operations. So you had read access to certain things, but you didn't have write access to them.
Yeah, we had these two contexts that were quite similar. And one was always a read-only, one was something you were meant to operate on. And it was really handy to have that distinction because it's C# and the const correctness is not really there. And so having that separation meant that it was really easy to write functions that were like, this isn't going to mutate anything. Whereas if you had a function that was taking in the mutatable one, there's kind of an implication that this function should probably return a game event of some kind because it's probably going to change something. And you should probably inform the player about it and that kind of stuff. Yeah. So we didn't allow so the AI did take in a mutable context. But that was primarily so that it could get access to its own like brain data. So you can keep track of some persistent data for things like who slighted me recently, and a bunch of really interesting little metrics that it would use to sort of make more human-like decisions. But then the AI would do things like it would take a pristine copy of the game state. So we could see like what is the state of the turn at the beginning. It would get a version of the turn state that had gone into the knowledge processor. So in Solium, you don't necessarily know everything about the game state. It's not necessarily like chess.
Right.
It's like there's chess. It's like you can see everything on the board, but you don't necessarily know what people have in like their vaults or like how much money they have and things like that. And we had a system that went through and removed all the information that you didn't know and then rebuilt bits of information on top again for things that you had learned over time or learned recently from scrying. And so the AI does have access to a turn state that has all the information, but it also has one which is like, here's the information that your player should actually know.
Yeah,
right.
I will admit, I use the true turn quite a lot because there's this truism in AI where it's like, the player sees an opponent's unit disappear into the fog of war, and the player has object permanence, right? So like I as a player know that unit's still hiding in the fog, but I as an AI no longer have that in my knowledge state, right? It's been removed from my board state. So either as an AI engineer, I have to implement this whole super complex system where I do like dead reckoning on where I think an object is, or I just kind of like have access to the true state of the world, but I sort of forbid myself from using that information in certain contexts. So yeah, we were feeding that information in certain places, and the preview state as well. We could write to the AI's local copy of the turn state in order to do things like, and this wasn't a functionality we really used that often, but we could move a legion to a new position and then kind of continue to process as though it was already there.
Interesting. Oh, so you could like update, like you would use that to say, this is a different state now. What would you do in this case versus trying to...
Well, like if I'm planning a turn, I can kind of place my piece where it's going to be if my intended move is executed, and then continue to process my following orders as though that had happened. So we were
which
able
allow
to
the AI to make more tactical decisions around troop movements and things like that. I think in the end, though, that system got a little bit complicated because the AI would then try and redo things like remove that same position, and it was just a bit easier
it's
to have
wait, that's a bad idea.
Yeah, and then it's a case like, well, no, it's already moved and things like that. And so I think in the end, those sorts of systems got replaced generally with more tactical systems about like, I am going to move this other thing here, and so consider that as part of larger
for
strategies.
troop movements, we had all kinds of basically like a list, like a blacklist of positions that you consider to be blocked rather than actually updating the turn state. So it was handled in a bit more of an ad hoc way for that specific thing.
And how are you actually stringing together this stuff? Like, was it just like a giant weighted? You said you're using like GOPS, goal-oriented action planning stuff. So like, what was the tool process? How did that manifest actually? I guess both technically and then from a design perspective. Like, did you have some like node graph tool that you like designed, or was it just, were you actually writing the code? What was that like?
Yeah, so the visualizing the graph, we used Miro. So I had this great big kind of spaghetti-o thing where I set down all of the actions, we call world properties, which is essentially an action. An action can require a given world property as a condition, and it can also cause a world property to be true or to not be true. And then GOP, what it's doing is essentially an A star. It's it's one of those like it's A star again. It's A star all the way down. The amount of kind of Dijkstra and A star implementations within the AI, like for doing different things. We were speaking about performance of the simulation before. A lot of that was network.
It's A star across the whole map for everything.
Yeah. But yeah, there's. Sorry, Macky, you wanted to chime in there?
I was going to say, and a surprising amount of flood fills as well that we had to do.
Yeah, flood fills are great. Some of my more expensive stuff got pulled out when we did an optimization pass, which was very sad. But so on top of that, that GOP kind of algorithm though is a utility system that's used to select goals.
Gotcha.
So essentially, you don't just have one goal, which is like win game, and then everything kind of comes out of that. You have different goals at different times. So a goal might be complete the kill 3 legions vendetta that you currently have, or it might be improve military power, or it might be improve tribute production, and then from there are different ways of there are different actions that will provide that goal kind of as a consequence, and the way that we selected a given goal that the AI would have was a utility system. So it would look at the state of the world, it would calculate a whole bunch of heuristics. And there's, this kind of like almost a tree structure of heuristics where we start from really basic evaluations that could be kind of at the level of a tile, at the level of a given legion, at the level of a given faction as a whole. So we calculate a whole bunch of things like, strength, openness for a tile, how, choke pointiness, and then these are kind of aggregated together to make sort of higher level heuristics. So, your base level heuristic is calculated from the game state, and then you combine multiple heuristics to make a higher level one, and you get to these really higher level things like how good at dueling do I think this faction is? And that would be calculated on the basis of all of the duelists they have at their disposal, all of the duelists I have at my disposal, all of the moves that each side has, the charisma level of each side. We'd be taking all of these things into consideration. And then on the basis of those high level heuristics, you then build the super heuristic, utility value that exists for each goal.
Right.
And then to select a given goal, you also have this idea of like, well, I don't want to be, I think it's Buridan's donkey, this idea of like, we don't want to be thrashing between two different goals when there are two of them that are both at like 90%. So if you have a current goal, you need to beat that current goal by a certain amount, but the amount that you need to beat it by decreases based on how long you've been in that goal. So you kind of have this like boredom, the AI gets bored over time.
And are you recalculating every turn or every like 5 turns? Like what is the, I guess, tick, so to speak?
Every turn.
Every turn, okay.
Yeah, every turn. And yeah, on that as well, there's also a whole bunch of kind of like faux, like emotion type stuff. So like you can get angry with a given faction, so you're sort of keeping track of slights and then sort of tracking your degree of kind of animosity towards a given other player. So yeah, a lot of stuff going on in there.
And then can you I'm interested. So you're mid game. Like, do you have any ability to like see the graph at any point to sort of understand what decisions are being made, or are you just? I assume it's something more robust than just like printing out a dictionary. But is there like how are you kind of mid turn? You stopping to say why is the AI doing this? You mentioned there's a scrubbing feature, but is there any way to actually see the brain, so to speak, when it's happening?
Absolutely. So, my kind of what I've learned from many years of doing strategy game AIs is like often what's happening is a really basic thing and you just need to be able to see it, right? So we didn't have a way of directly visualizing the graph. What we did is more like visualizing things as a tree structure, which is really easy to implement in kind of, I guess floating window like inspectors. We had these really good sort of in-game debug tools. And so what you could do is say, you've selected, or you've got all of these goal utility values, all these possible goals, right? And then you could sort of unfold a given goal and see all the neighbors of that goal, and then unfold all the neighbors and see all the neighbors of those. So you were exploring the graph as a tree structure rather than exploring.
It's almost like the profiler in Unity, kind of the way that works.
Yeah. So it was reusing those kind of same UI tools to do it, and so that enabled us to understand like why have you taken this path and not this path? Because often that would be the thing, like why are you choosing this goal, or why are you choosing this this particular path as a solution to this goal, when clearly this other path would be better. And so we can actually look at those two paths by kind of unfolding them and looking at, what is the, because it's A star, there's a cost associated with each node that it goes through on its way to a sort of terminal action, which is an action that has no precondition that hasn't been yet fulfilled, would be an action that we can actually take as a step towards a goal. And this is all kind of GOAT stuff that you can read up on.
How is this being sort of persisted or like serialized turn to turn? Like if I save my game and then I open it up again, like I save my game, close Solium, open Solium, load my game, is that decision tree persisted in some way? Or is it like it's going to redecide, the start of the next turn?
That's the beauty of determinism. Yeah, so...
so the AI is completely deterministic too,
yes,
like the decision tree.
It is.
Gotcha.
That's the wonderful thing about AIs is they tend to be so complicated that you don't need to throw dice ever really, because a random number generator in a computer is deterministic as well. It's just so complex, so entropic that we perceive it as random. And so, an AI, like a complex AI opponent is generally behaving in such an unpredictable way that you don't really need random on top of the evaluation it's making. There are obviously things that are saved into the game state. So like the AI's level of animosity towards each opposing player needs to be serialized because that's based on historic information.
Right.
But yeah, there aren't actually that many things that we needed to save. Like, for instance, all of that stuff about marking areas of the map as no-go areas because they've already been claimed by other legions wanting to move through them. That doesn't need to persist from one turn to another. It's volatile kind of analysis information that's calculated from the turn state.
Right.
So we could just recalculate it.
And then I'm trying to think how to describe this. Like, was there any sort of like higher level authoring tool you were using for AI stuff? Or are you just doing like, you've got 600 functions that all return a float value? Is that like what we're talking about, or is there something different?
Do you mean for the heuristics, or do you mean for the
how is the AI sort of actually being processed? Like you want to add a new heuristic or something. Is that a function? Is that some data somewhere?
I just roll up my sleeves and write some C#. Honestly, like there's a part of the code that's going to do like an analysis of the game state and calculate heuristics, and there's a place to store them, like a structure that you can add stuff to. But essentially, you're just writing in like extra logic. You're making sure that you're calculating things in the right order. Obviously, when heuristic A needs to use heuristic B, but we didn't have any system that's like, I don't know, creating a dependency structure that will automatically run things in the correct order. That dependency structure was literally just like putting the subroutine calls in the right order, and that worked fine for us. Yeah.
And there were some systems where we could attach like little bits of AI metadata to our data as well to say, this is something that's really good for AI, or some additional weights. But but for other systems, like say the edicts, where we're deciding between A or B or whatever, the AI would need really custom logic to determine like, is A better than B? Which one should I choose? So like that system had to be kind of all written by hand and all very interpreted.
Right.
For a lot of the items, like some will give you attributes, and the AI would actually analyze those attributes and even simulate fights. Like if I put this item on, would I be better at killing the target that I want to kill if it gives me +3 melee? So it would automatically take that into consideration. But if you have an item that's like, this item makes you go first in the melee, make the melee phase go before the ranged phase, it's really hard to evaluate what that does. And so as Macky said, we just went in and like tagged the data with basically how valuable is this for the AI, and that's in that data object.
That's actually a good segue to like kind of like I don't know if it's like a bigger part of the game, but there is a lot of data in Solium, right? There's characters, there's archfiends, there are praetors, there's encyclopedia, there's text, orders, rituals. All that data is like static, right? How was that being authored? How did you make it? How is it being loaded, etc.?
Yeah, there's actually a little bit of a longer story for this one. It's quite interesting. Especially in terms of authorship, we actually started with a different designer on the project, and he was like a Excel spreadsheet master, like Google Docs master. Loved working out of that. Didn't want to work in Unity. And so we actually invested a bunch of time quite early in the project in developing a system to synchronize data in Unity with to and from data in the spreadsheets. And it would also auto-gen the data for us and everything. So all they'd have to do is add columns and things, and it would just automatically generate all the data. We spent a few months building this system, getting it all up and ready, finally got it operational, and then the designer left, and we got a new designer, great guy, Anthony. He came in, he's like, oh no, I just want to work in Unity. And so we just ended up scrapping...
Just rip it all out, yeah.
Rip it all out, and honestly, I think that was a better decision, because it meant that we really did have one source of truth that was versioned, because spreadsheets weren't really versioned or anything like that. And so that was better. It was a lot better, in my opinion.
We're using spreadsheet data synchronization at Twice Different, and it's sometimes tricky when you have multiple branches that are versioned in Git, and you're working, say, on a build for Gamescom, a build for Steam, a build for this, but you've only got one spreadsheet, the data that's being synced. And so how do you maintain, like, what branch is that data supposed to reflect? And I know that Amplitude was allergic to the idea of syncing data sheets with the game, because in the past it'd been like, if we let you import the Excel spreadsheet into the engine, next thing you'll want us to export the engine data back into the spreadsheet, and that's madness.
Yep. And we did that. But luckily we never actually even considered needing to run multiple concurrent versions or anything like that in the data when we built this system, and we would have run headfirst into that issue
100%.
if we hadn't pivoted.
Everyone starts with Google Sheets, and then everyone, for one of a million different reasons, is like, wait, this is terrible. Everyone's very excited that first time, where it's like, if you just have rows and columns and a single sync point and a single build, yeah, it's great, it works fine. And then if you have anything of any complexity that needs any sort of nesting or anything, you're like, wow, this is terrible.
Yeah, I do think we did use the export function once or twice after that fact, after we authored a bit more data, because we realized that, hey, we can actually export the data to a spreadsheet and then do analysis on it.
Right. Yeah.
And that function was really useful. But yeah, still a lot of work for not a lot of gain.
I mean, for keeping track of the data and kind of tuning things, I was working in Excel for any like heavy duty math that I wanted to run, like analysis that I wanted to run, and Google Sheets. And that was like, from the perspective of design, like the sheets were the master copy. But from the perspective of what's actually versioned, definitely the game was. So it was like more like you fiddle around with things in the sheet. You have your graphs and charts and mathematical models that are being run on top of that. And then when you're satisfied with it, you move it into the engine and actually version it.
So you were still maintaining the sheet the whole time?
Oh, absolutely.
Okay.
I think that much as I love kind of, I suppose, the protections and the sort of, the things that you can build into a Unity inspector to make sure that you're referencing the right kind of piece of sub asset, or that a given value is within the right interval or whatever. The tool that we had in a spreadsheet, the ability to give you an overview of the entirety of the game data of a certain type is really useful, and it really makes it easy as well to do charts and to do analysis in a way that you can't do quite so easily in a Unity inspector. And I feel really bad saying this because one of our programmers, Jairus, made this absolutely amazing like asset explorer that lets you kind of search for assets and find things of a given type. And you could even like write little queries like, hey, find me all of the things of type Legion that have at least 10 hit points. And I did use that as well, Jairus, and it is absolutely great, and appreciate your work.
We love you, Jairus. Thank you.
But I did use a lot of spreadsheets as well, just because designers embrace chaos. What are you doing bringing order into my chaos?
So you had 2 copies of the data. There was one in the spreadsheet and there was one in Unity. The Unity data was presumably the copy that got baked. Was that were you writing custom inspectors? Were you using Odin or whatever? What was the actual authoring process for that data? Was it all scriptable objects? Was it just raw JSON? Was it serialized whatever?
Yeah, so we had a custom system that predated scriptable objects that came out of that monolith package, which used mono behaviors that were called data configs, which operate in a very sort of similar way. The only difference is they're a game object, and then those would be baked out into a sort of a database object, which was still just a collection of those same game objects, essentially as prefabs.
I was also to quickly sidebar that I mentioned I looked at sort of in the game data folder in Steam, and I saw that you had a ton of addressables, but the addressables themselves were the data. So there's a 1-to-1. I don't know if it's 1-to-1, but it seems like it's close to 1-to-1, addressable package with object, but that was because the object itself is literally a game object. The data itself is a game object that's saved in the addressable asset.
Yes.
Is that true?
Yeah.
Gotcha. Okay.
Yeah. So, we'd have a game object, which is the representation of, so it's kind of weird. So what we'd have a prefab, which is, say, Pandemonium, it's a ticket, and it would have a static data config on it, which is just a mono behavior, essentially, and that mono behavior just owns a C# structure, which is part of that simulation core and part of that simulation core library. So it has no Unity on it no Unity on it whatsoever, which also means it can't use things like Odin or any other fancy inspectors. So we'd have to write all of our own custom inspectors for some of this stuff, which we did end up doing for if we wanted to reference this unit has this ability, and that ability is part of the simulation core. It's another game object, so we had to write our own custom inspector to sort of match the IDs up and do everything correctly there. Shout out to David Little for that one.
Good job, David. We love you.
Yeah, no, David did so much. He's an absolute god-tier programmer. So everything, all of the stuff around the tone outcome sequences and stuff as well, that was all David. Absolute mad lad. But yeah, so those game objects would also then have a piece of visual data, which would have what is its name, its string, and everything, and that's what the client would use to actually visualize things, and that would also then link to the various assets that it would have, whether or not it's using a skin to mesh like a Titan, or whether or not it was using a Legion or something else in between the Pandemonium's actual thing, if it was a structure, what walls did it have, because Pandemonium has its own unique wall structures when it's under attack and things like that. And then what would happen is we had another process which would essentially go through all of the...
Sorry, just real quickly, just on that, is that is there sort of any contract between the game object that is the Unity side with a model, whatever, and the data? I guess said differently, it's a tree is a horse is a chair in game development. Is everything on the map the same thing effectively? And you're just changing it's either Pandemonium or it's mountains or it's an army. Are they all literally the same thing, or is it?
The terrain
different?
Is a different system just because it has to support all the world wrapping and all that.
Sure.
It's a lot more advanced, whereas all of the units do derive from a common base, which is we call them game pieces. And so, a stronghold and a legion are both a game piece. They're just different versions of it. One
moves and one doesn't.
Yeah, but at the same time, the movement system doesn't care. It'll grab it and say, "Hey, you're moving," and it's I don't have any way to do that. And it would go, "Okay, well then that's fine. I guess when I wrap up now, since you don't actually have any timeline, I'll just move you to where I want you to be. And that actually was a problem because we did actually have some item. There's an item, I can't remember.
Crown
of
of
rings.
Alacrity.
That's it.
Yeah,
It gives,
Steph was using it to... Well, you tell the story, Macky.
Yeah, so it's an item that gives you +1 movement to all of your legions, except that it was misconfigured, and instead of applying to just legions, it would apply to all game pieces, which included your strongholds and other things, which meant for a brief window in our game's history, you could actually, if you equip that item, you could actually move your stronghold, and then she was using that in one of our internal test games to like attack other people's strongholds, and that was very funny because they put their walls up and shoot arrows at each other, and it was very. I don't know if you've ever seen this movie, The Adventures of like Baron von Munchausen.
Oh yeah, Baron von Munchausen.
Yeah, great movie. But there's this awesome scene with like the corporate raiders where like two buildings come together and they're like jumping through the windows and beating on each other. It was very much that. Yeah. So everything was a game piece.
And so those data, the data that you were authoring, it was game piece data effectively. There was no but I guess I don't know if you use the same system for terrain, like you're mentioning, but everything was like effectively shared the same data structure.
Yeah, there was also a separate one.
Units can have walls like that. That's technically possible if you configured it that way.
Yeah, I believe so. Like I said, we did go very object oriented, so everything derived from game piece, but I think it was I think we called them.
Oh, you derive? Well, what did you derive? Was there literally? Is there a class per? Thing?
Yeah, pretty much. And
interesting.
Yeah, like I said, the team was really not interested in going entity component for this other stuff.
Yeah.
So
I would have thought you would like fat object mode, where it's just bullying flags. It's a whatever versus. I'm surprised you were object oriented.
We did fat a lot of stuff. Some things not so much. So we did have like a specific thing for fixtures, and which were any structures, so like a stronghold and a place of power, two separate objects. Like they have different data layouts slightly, but they both derive from fixture. I don't think there was actually anything different between the two. That's
the thing, right? Is you look at it too closely, you're like, this actually need to. What was what were you getting from extending it?
Yeah, at that point, not too much. There was definitely some points where we'd have
like lack of tech debt and consistency. Kyle.
I mean,
that's
it actually caused a couple of
game.
Because there's a weird thing where your stronghold, the one that if it's taken you're eliminated, is a specific stronghold. And so you're not really, for any of the logic around player elimination, you're not looking at the type of fixture. You're checking player object and then checking what their stronghold ID is. And we had a lot of problems around the fact that if you capture another player's stronghold and then a third party has a vendetta against you that is to capture 3 places of power, I think there's a bug, or there was a bug, where recapturing...
You can capture the first one or something would satisfy the condition?
It wouldn't, because it's not technically a place of power, it's a different type of object. And so there are a couple of edge cases there that emerged where it was like, but then, there's a big question around the language that we present to players as well, because we didn't want to use the word fixture. We didn't want to use the word game piece. So we were always saying things like, Legion or Titan, or we were saying, stronghold or place of power, rather than saying, fixture. And there were obviously attachments like the artifacts and predators, which derive from game item, which is actually a class above even game piece.
Game item was the closest thing we had to an entity, really. So everything in the game was a game item. And that included players, abilities, everything. Everything derived from game item in the end.
I think a ritual that you're currently maintaining is a game item. I think a scheme is a game item as well. So like one of the objectives that you currently have active. And this
it was, and then there was a bug where they could be destroyed by an event accidentally. And we were just like, you should move these out. they don't fit the mold.
And what was the shared base class for game item was useful because of X? What was just that it is a thing that a player...
Yeah, so when you're having... because you can
has is weird because sorry, go ahead.
Yeah, it's mostly to do with the way that certain things overlap. So a good example would be like ongoing rituals are game items because they go into those ritual slots, but there are also certain artifacts that go into those ritual slots as well.
Right.
And simultaneously, you can have things like praetors, which can sit in your vault and can also then be attached to your legions and things like that. So there was just a lot of common sort of attachment behaviors between a lot of things. Like they can be slotted, and so we needed to have a sort of like slottable concept for things, and we thought that would just make things a bit too complicated, especially when we're dealing with the rules between then we have to have the slottable concept that also understands that not all slots are the same and certain things can't go in other things. Like you can't attach a praetor to a ritual slot and things like that. We thought,
those are based off of the inheritance tree, not the data. Then is that what you're saying?
yeah. So
gotcha.
It's kind of weird. So we had the inheritance tree, but then we also had enums on things, which would decide what they are, and we tried to drive things via the enum rather than necessarily looking at the type, and that was so that we could really go like fat if we needed to, or switch stuff to entity and rules. We really tried to avoid using the actual object's type as much as possible and trying to infer things from more data-oriented sources. But yeah, a lot of the time.
It was handy for the UI. Like I wrote a lot of at least kind of at the implementation level, the turn log messages. So things like Astaroth has cast a ritual on you that has caused this legion to be destroyed, or that has caused this item to be unequipped, or also the error messages that pop up. So there are hundreds of these kind of like turn log types, and or not the turn logs themselves, but the effects within them. Because there are a lot of rituals, they can do a lot of things. And so you can
like sort of click them all, and they will resolve to different UI panels and stuff when clicked.
Yeah.
So it's not there's not just like a message. It's got some sort of target of some type.
It will have there'll be a pop up, and it will nest, for instance, like a little portrait of the legion that was destroyed, or if someone cast a ritual on you that destroyed one of your schemes, then there is equally a little portrait that pops up that shows, an icon for the scheme. Or if that ritual was used on you and it was like a dispel, the demonic interference ritual that blocks you from using rituals, it will stop all of your active rituals that were currently ongoing, and there'll be messages with that little icon, and the little message saying this ritual of yours has been stopped. And so having this kind of common ancestor for all these different types of object made it a lot easier to display them in the UI. Because, from the UI's perspective, it can just say, oh yeah, you want me to display, a game item with some text next to it. Okay, well, I'll pull out, the icon and the name of this game item, and then, display your kind of custom text.
Yeah. Having that kind of association where like every game item as part of that sort of like data contract meant that it had an equivalent visualization chunk for like a game item, like it met a minimum criteria. So things like name, description, having an icon and things like that. Whereas more advanced variants of the game item, like say the game piece, would then also have things like, well, what is your board visualization and things like that. But yeah, it just meant that we could write a lot of systems around game items, which allow us to just lean back on saying, how do I display this game item in text, whatever. It's like, cool, well, it's got a name, it's probably got a link to the encyclopedia that we can hot link you to, an icon to show, and it might have some additional tooltip visualization data associated with it, things like that.
Yeah, and the logic for attaching game items, for instance, like a lot of that logic is shared. So for instance, if I want to reassign a game item somewhere, whether it's to a game piece or to my vault or to a ritual slot, I'm always going to need to own that game item. Like it's always going to need to belong to me. And so you can write kind of a shared piece of logic. And that's important because we want to have the error messages that pop up that say, oh, we couldn't reassign this item because you no longer own it because someone stole it, or you couldn't reassign this item because it was destroyed. Any number of different types of items can be destroyed before that action can go through. And so we don't want to have the same logic for generating an error message in like 20 different places. And so by having that, like, I suppose we could have used interfaces rather than, like a parent class or any number of different architectural decisions, but at least we're able to factorize an enormous amount of kind of error handling code and also the turn log generation for the effects.
Yeah, and we did that with a system called problems. So anything that's returning a game event could also return a problem. It's very much.
I think you said that earlier, and I didn't know. You're talking about like the thing that couldn't move. I guess that would be like a problem where it's like this can't move, and you're like, okay, well, either resolve the problem on the Unity side or like ignore it.
Yeah, and we could always tell the player as well. So a good example would be like you'd have a game event, which is like I'm trying to move here or whatever. It's like there's something in the way, like somebody's put a legion there that we're not at war with and we can't fight or something, and so you'd get a problem back. We're just like couldn't do it. I was blocked. And then the visualization system would know that, okay, that couldn't happen, we'd have it in the turn log, and it would understand, like, what that is. And because they're just pure data as well, and they're, like, kind of tagged, like, I know that this is I can no longer move problem, and here's the details, it meant that it was really easy to do the translations and localization into other languages, because the service not trying to do anything fancy with it. Whereas I think in the original Soul... Sorry?
I was thinking of Jarrus's joke, I've got 99 problem subclasses.
Yeah.
I think we had at least 99 of them by the time we shipped, each of them with kind of specific like data that could be passed into them to provide context.
I do know because there's a bunch of automated tests that we wrote to test serialization, determinism, and so we just use reflection to look up anything in the simulation core which could be serialized, and we'd instantiate one, and then we'd go through all of its properties, and we'd start filling it out with gibberish. So, if it's a number, we just pick a number. If it's a float, we pick a float value. String, just assign some random string data. If it's another serializable object, instantiate it, put more junk in it, and just keep going up to a certain depth. And so we'd fill these objects out and a lot of stuff, and then we would serialize them, load them, compare them to the original, make sure that everything is still the same, and that everything makes sense. I do remember, because all the problems are serializable, you could just type problem into the test runner. And I think at one point, there was definitely over 140 of them. Yeah.
So much can go wrong in Solium.
Yeah.
It's just strategy games, man. It's like everything can always go wrong.
Well, I think there was over 240 entries in the turn log system. There are 240 different turn log events that can come up.
I mean, the problems also needed to be displayed as a preview, because the interface needs to be able to tell you cannot do this because there's not a slot free, because you don't have enough money, etc. And so it's actually using the same problem, it's just displaying it in a different way in the interface. And so, attempting...
Were problems game items? Or is it separate?
No, just little pieces of data. It's my biggest regret is not really unifying problems and game events into a more common system. Most things would have, like a game event would typically own a problem if it didn't work in a lot of circumstances. And other variants would have game events that sort of were problems in and of themselves. It was a little bit iffy. It could have been a bit better architected, but it was one of those things where when we kind of realized it was getting a bit out of hand, there was already so much data already there, and so much more data. And so much more data to come, and we were like, I think we just gotta roll with this. And so we sort of moved it a little bit more to a bit more of a Golang approach, where you sort of return a contextual piece of data and or an error simultaneously. So
it's almost like a result type or something.
Exactly, yeah. And so you get both back, and then you would just check is the result type a problem? And if it's not a problem, then it's successful, and okay, we move on. And I chain the game event in. But if the game event is null, then it's probably a problem.
Were there other things that you wish were different, like that you were like, oh man, this is just we're so close, and this is not. Yeah,
so I think that's a big one for me. That's one that we definitely fixed.
It's pretty minor, all things considered. That's that's not terrible.
Yeah, but just the sheer amount of stuff that got built on it. It's one of those things we probably could have caught a bit earlier, but just didn't. I think the big thing is we had a big push for one of our milestones. It might have been a Gamescom build or something like that, but we were just really pushing for pushing a lot of features in, a lot of we were going wide rather than deep at that point. And then 1 minute I'm like, oh yeah, that system's holding up okay, and then I sort of go off and do a bit and come back, and so many commits have gone in, so much stuff has been built.
Put a to-do in, and then never.
There was an enum which is tracking a bunch of these things. It was had 15 entries, and I come back and it's up to 80, and I'm like, oh no,
There's a switch statement. I think that switches across. It's either problems or turn log effects. I think it's over the effects. And that switch statement is essentially associating a type So it's doing like a pattern matching on the type of effect, and it's then associating like a localized like a string key with it.
Sure.
And it's like hundreds of lines where it's,
every possible option.
Because, that was kind of done at the end. Like the system went in, but it wasn't battle tested until near the end, where we actually like, oh shit, we need to get all of these like 140 problems and turn log types and so on. And a lot of these things you don't see until you start really getting all that content in.
And you're like, oh, this is getting bigger.
Yeah. I think
anything else?
I think moving more towards entities and things. It's something that we really, at the start, it was very much a case of that the team wasn't going to have it, and we were all fatigued.
Yeah.
And everyone was like, we just want to make like a game the way that just feels natural kind of thing, even if it's not necessarily the most optimum. And I think we sort of like as we went that route as well, like we did start trending back towards entities. Like. We didn't start with the game entity concept, but we ended up doing it because there's game item, but there's also game entity that got ended up at the end, which unified Archfiend data with game item data in a common way, which also meant that we could display Archfiend's data in tooltips the same way as game items. To be able to say like it's got a name, it's got a description, it's got an icon, some sort of additional association, things like that. We ended up really sort of moving more towards that, but much later in the project, which meant we sort of had a bit of a bit of B, and I feel like that could have been handled a bit better earlier on. I think we should push a little bit harder to maintain some of those more common concepts. But other than that, no, I think the architecture of Solium is really good. I'm really proud of it.
The game it feels solid, which I know is like it's not just a factor of the programming or whatever, but like there's a lot of stuff going on, and it doesn't necessarily seem like it's collapsing under its own weight.
It's yeah, and I will say this as well. It's something that we got a lot of kudos for from like QA and designers and producers and stuff throughout the development. But with all the automated testing and the approach to architecture, the game was very, very rarely ever in a broken state. And it was usually a case of like a feature or something would be broken. But because we also had a really strong focus on building tooling in GUI windows and things like that, because our UI was usually a little bit behind because there was so much. Also, massive shout out to Tash and Alex for the
UI it's literally a different game. It's like for strategy games, you're literally just programming another game on top of the game.
Yeah. It was Tash and Alex did such an incredible job for the UI of the game. It was a lot. I've just lost my train of thought in the appreciation of them.
You're just it's good that you've run out of ideas of like things that could have been better, because the answer is like, oh, it's pretty nice.
Yeah, it just sounded well. It wasn't down very often. It was really good.
Yeah, the automated testing bit also, I think, and I don't know why this happens on some projects more than on others, but the fact that we were regularly playing the game with each other, like really every week, I think it was good that production saw the value in that and allocated time to people doing testing. But I think, more importantly, like we were enjoying playing the game with each other. And so we got a lot of hours in, attacking each other with places of power that weren't supposed to move and that kind of thing, and that led to the game being, I think, stable, both from the point of view of the technical side of things, but also from the point of view of the balance. So yeah, very, very satisfied with how things panned out.
Yeah, it was very motivating for people to fix bugs, because it was a case of like, no, I need to fix this bug so I can use this feature in this next turn to like get back, somebody who wronged me previously.
And the turn counter is like, I've got 72 hours before the turn goes through.
That's
so
incredible.
I have to fix
you're like, can I get this fixed and pushed? Yeah.
Yeah.
I guess my last question is like, was there anything otherwise that you all did kind of in the scope of what we've talked about so far that you thought would be worth mentioning? Anything kind of special systems? Did you have a custom scripting language? Did you do any other like weird whatever stuff that kind of made the project happen? Or do you think we mostly covered it?
It's one of those questions where like, I think I've covered most things, but I know when I walk away from this, I'm like, I should have mentioned that thing. That one thing. Like, I know there's going to be something. I'm just racking my brain and
put it in the podcast notes.
Yeah.
Macky got back and said,
The schemes are worth mentioning. Just the fact that we talked about game events. A lot of the way that the schemes functioned, and I believe the achievements as well, is that they were just event readers. So like, events would be fired by various game transactions, and then the schemes would be there watching and kind of filtering through them to see whether they should be completed.
Yeah, there was kind of two of them, two types essentially. So rather than we're saying events, but I want to be clear as well. This isn't like in programming the sort of like tick to tick events or anything like that, or in an update loop. It's really just a case of when the turn ended, as part of the turn processing stack, right at the end, or right near the end, it would go through all of the schemes and achievements and things like that, and just go through all of the game events essentially and say, is anything listening or caring about this? So if you have a scheme to destroy 6 legions, it's just looking for the event that's like, hey, a legion was destroyed, and then it would go up the chain of that game event and say, well, who did it, and was it this player, and things like that, and then it would just take over. And the way it sort of worked, I was a little bit inspired by Minecraft Redstone in a weird way. Here's the thing, I'm terrible at Minecraft Redstone, but I love watching all those videos.
I made a computer with Minecraft.
Yeah, all of that stuff. I love it. I'm obsessed with it. I don't understand a tenth of it. I just love the creativity, the passion that these guys have for engineering with like weird tools. I think it's great. And so I was inspired by Minecraft Redstone, which has a really interesting like signal property, where it's about redstone, when you monitor it, it comes out in signals. And that's the approach I took as well. So for instance, when it does the thing to say, hey, how many legion, it sort of asks the question, how many legions did you kill this turn? And then it gets a signal read back from that, and then it just accumulates. But that system also works the exact same way if you need to query the game state. So for instance, if you need to query the game state for a goal that say hold or own 3 legions, it can just query the game state in the same way and say, well, what is the current signal of the amount of legions that you own? And it gets back a value. And that value either satisfies the criteria or it doesn't. And so it works in this kind of like unified signal way, and either accumulates or it accumulates and then checks the value, or it just checks the value.
This was like one of these weird things where, like for Cantata, what I did of the objective system, it was like sort of similar, where it was like surprisingly complicated to be like, it's like kill 5 of this unit, and then people are like, I want to see that I've killed 3 or 5 of them, and it's like that's kind of hard, but also like you have to sort of internally understand like what you're describing is when does something get killed, because it's not just I attack something, there's a lot of other stuff that could happen that would have a unit to occur or have that specifically occur. And especially if you have like some conditions about how they're killed or something, that the actual internal structure of the objective is effectively a list of like listeners of some type to say like this all technically satisfy, the conditions set by the scheme, or in Kata's case, an objective. And then internal to that, like effectively instance of that objective class, there's an accumulator to say like, okay, this is actually, 2 have happened now. And it's hard because if you're not already operating in a paradigm like what you're talking about, where you have this concept of an event, it is very hard to retroactively do that, because you're just going to all the places in code where this could possibly happen and effectively just like actually emitting an event to say like this. It's more like an analytics event where it's just like, scattered across the code are these places where we like will potentially accumulate a value to an objective. But having something like what you're doing where you're like, here's the effectively transformed state and like the events, is there anything in here that satisfies this? Is like I don't know, it's like very elegant. It's nice for sure.
It certainly makes it easier to write them, because you know where you're supposed to go as like a script kiddie working once again high level in the code base. I just went, this is where all the schemes live. I'll just write a new kind of like filter, basically event filter, go through the events and check things. And it keeps it very tidy and sort of self-contained within that.
Yeah, so you don't get that like bleed where like every function call might end up emitting some sort of like state operation. It's like, this is where it happens.
Yeah, absolutely.
This is where
One other system that I now, this is the system that I would have walked away from and be like, I should call this out. So I'm glad we actually had to have this extra chat to let me remember it. But I'm going to call out the modifier system that we used. It's a little bit different to how you would normally architect a modifier system, I think. So when
it's like attaching praetors and like getting like +3 melee or whatever.
Exactly, like those sort of offsets. So because we need to track for our UI where everything is coming from. And so the actual simulation core does that in the modifier system. It sort of registers like you have plus like this is the value. It's called a modifiable value, and it has a collection of all the different things that are going on. Like, this thing's giving you +3 or minus or whatever. Very much inspired by State of Kings 3 and their sort of system, where you can sort of see all the values and all the changes.
You just see the stacks of +2, +2, +3.
Yeah, or +25%, and all that kind of stuff. Now, traditionally in other games that I've seen, other architectures, you do that on like an attach-detach kind of functionality. Like when you attach the item, that value gets added, and when you detach the item or remove it, the value goes away. But I've worked with that architecture before a long time ago in an RTS game, and found that it just absolutely, one of the biggest causes of bugs and game-breaking bugs as well would be when you find a way to make something attach and then not detach. So you just end up being able to just consistently reapply the same modifier over and over again, and then you can just essentially get an infinite power. Now that's a huge problem in these sorts of games, and if it enters like a live thing, then it has a broken meta, downvotes on review scores, all that sort of stuff. And because Solium has the architecture of only really processing at the end of the turn, and that turn is allowed to be a little bit more expensive, we don't have to recalculate every single frame, we don't actually store that state, or we don't actually do that on attach or detach. We actually recalculate all of the modifiers that are applied to everything when things get dirtied. And it just means that there is no ability to do that, because if something is removed, then we recalculate everything, and everything updates. And it also means that when you have things like, this thing is in this other thing's proximity or whatever, it all updates cleanly. And we also don't run into odd, and we also have a very consistent case of like, this thing happens before that thing. So this thing's modifiers can't affect this other thing specifically or in a certain way. So that means that, for instance, because we have units standing next to other units, and they offer some of their power to that unit, if you attach a Praetor, then you get that legion that has more power, and then you need to push that power onto that other legion. You then need to have a case for that in your attach-detach to understand that relationship, and that really convolutes the code, whereas we don't have to worry about that at all because we have a very discrete set of steps. And because the system is using just the enumerator system, we're allowed to modify what's happening as we're going through. Like, we can actually mutate what's coming next a little bit. We actually have a load-bearing, like with a comment that says that this is a load-bearing enumerable that we're iterating. Do not turn this into a list. Don't don't pre-allocate this.
I remember that load-bearing comment.
Yeah, no, it's really important. Don't do it.
Yeah, because it's like I get what you're saying, because like there was a to just abstract this a little bit, right? It's sort of like a buff debuff system where if someone got a buff, you probably there's gonna be a list somewhere that tracks the buff, and then the buff should go away. Versus like because the structure of Solium specifically kind of lends itself to like you can effectively just bake the data and recalculate it.
Yeah.
Versus like that. How do you track the dirty state? Does the value listen to dirty, or is dirty like global where it's like game state change, therefore recalculate?
Yeah, so this is the part that is dirty in and of itself, is we didn't actually use a dirty flag. It was more a case of like, because we do have a very sort of functional style, we have like big functions which are like, do this thing for me. It was really up to those functions to sort of say, well, I know that I need to update this thing, or I need to update like everything, or update kind of globally. And so it was really up to those functions. And then there were other systems as well, like the combat system, just if two things were fighting, it would just recalculate everything on the game board before the fight. It was just like, I'm not taking any chances with any dirty states.
Right.
This has to be perfect and clean and exactly what people expect at this point. And so it was a bit of a half-half where some systems would be like, I made some changes, I'll update, and other systems which were taking responsibility for saying, no, I'm about to like read these values, I need to make sure that they're up to date. And so it's a little bit messy. There's probably a gap or two still in there somewhere. But and then at the very end of the turn state, probably right before or after, probably before your schemes and your vendettas and stuff are updated, we update the modifiers as well, so that you get a nice game state back that has what the values of everything are at the end of the turn.
So when I see just use the melee attack value, and it's like +3 from the Praetor I've attached, When I see that +3, is that coming just from like game state? That's not literally looking at a list, finding somebody and applying it to my base value. I just have like attack value and it's just like 5 instead of 2 because it's like baked on there.
Yeah.
Is that like...
So the value is baked. So like there is a value under there that is 5. There's also a value under there which is like, here's what the value was without any modifications, and like at various levels there's like quite a few values. And then there's another section in there which is like, here's the list and all the modifiers and what value they're doing, which is being tracked as well, so you can really see like what's been affected.
But you're not literally having to like search the modifiers, like the attached modifiers. It's just
no.
Here are modifiers.
Yeah.
Here's the value, and when it gets dirty, this value changes.
Yeah.
And you could back calculate it from the attached modifiers, but this value that you're going to look at is the right value.
Yeah, correct. Yeah.
That's nice. That's pretty nice.
Yeah. And then, again, David Little did some really nice caching work there as well to make that performant too.
Yeah. This was like a big sticking point of Cantata because we have things that have like auras or radiuses. And if you move something, kind of like what you're talking about with the 2 adjacent units, they can like buff each other, you know? Yeah. But it's like, it gets really sticky really fast because if a unit moves, it could be touching, you know, anything in its movement range. And if its movement range is 5, all of a sudden you have 100 new tiles that might have something in there, and so you're like having to like, and then we were doing I think we ended up doing with a modifier thing where it was like we cache a list of who was close by, but just baking it as like, it's not bad, it works.
Yeah, I mean, still smoke and mirrors under the hood, right?
yeah Let's end it there. I feel like I got everything that I want to talk about. I feel like you all told me some interesting stuff. Thank you for being on the 3rd episode of the podcast. I had a great time. I hope you did too. Where can people find you all? League of Geeks has like, unfortunately, it's, compressed a lot in the last few months. So as I understand, neither of you are there anymore, but I know that you all are still working in games. And what are you working on these days?
Yeah, so I'm currently over at Playside Games, but yeah, can't talk about what I'm working on at the moment. Hasn't, NDA say no.
As someone who's worked on strategy games for the past decade, I can't imagine what you'd be working on.
I'm now freelancing as a designer. I'm working with Twice Different at the moment on Winnie's Hole, and you can find me on my website, wilberfast1l.github.io, or around the internet, Wilberfast. Yeah, get in touch if you have any contracting work for me.
Otherwise, like a fairly low profile, you'll just have to go search me on LinkedIn, essentially. Just Peter McIntosh.
Let's say if you can have a low profile and still get work, that is like that's the way. No one wants to maintain a social media presence.
Yeah.
Well, thank you both. Thank you, listeners, as well, for listening to the podcast. I hope you guys have a great rest of your day, and hopefully we'll see each other at some conference in the future and talk more about this and many other things.
Yeah. Thanks so much for having us.
Yep. See you guys.